A reinforced concrete rectangular beam, 300 mm wide, has an effective depth of 500 mm and is reinforced for tension only. Assuming F prime C is, or the specified compressive strength of concrete is 21 megapascal, and the yield strength of steel reinforcement is 345 megapascal. Using the NSCP 2015 provisions, determine the maximum steel ratio, determine the maximum steel area required, and determine the maximum ultimate moment capacity of the beam section. Okay, so if we're going to illustrate the given, we have a width of 300 millimeter, and then the effective depth with reference to our area of reinforcements taken from the centroid of the section of 500 millimeter. First, the specified compressive strength of concrete is 21 megapascal. Since it is less than 28 megapascal, therefore our beta 1 angle is 0.85, and the yield strength of steel reinforcement is 345 megapascal. Determine the maximum steel ratio. Okay, so for the maximum steel ratio, we have a formula. Rho max, or the maximum steel ratio, is equals to 3/7 multiplied by 0.85 F prime C beta 1 over Fy. Okay, since the required variable are already given, we're going to direct sub the values on the equation. So rho max, or the maximum steel ratio, is 3/7 quantity 0.85 multiplied by the specified compressive strength of concrete 21 megapascal, and beta 1 factor is 0.85 over 345 megapascal for the yield strength of concrete. So cancel na yung unit ng megapascal. Therefore, yung rho max natin is equivalent to 0.01885. So that is for the maximum steel ratio. Next, determine the maximum steel area required. So we have a general equation for steel ratio. We have rho is equals to AS over BD. However, we are considering the maximum condition. Therefore, if we're going to consider the maximum for steel ratio, therefore we also consider the maximum area, which is the one or being asked. Okay, manipulating the equation, AS max is equivalent to the rho max multiplied by the dimension of the section, or BD. Okay, so the value for Romax is 0.01885, okay, multiply by the base of 300 millimeter, multiply it by the effective depth of 500 millimeter, we have AS max of 2827.50 square millimeter. So this is the area of area of steel reinforcement under maximum condition. Next, we have letter C. Determine the maximum ultimate moment capacity of the beam. So, ultimate moment capacity under maximum condition is being asked. Okay, so for the maximum moment capacity or ultimate moment capacity under maximum condition, we have an equation of reduction factor multiplied by the rate 51 over 140 beta 1 f prime c b d squared quantity 1 minus 3 over 14 of the beta 1. So this is the general equation, or this is the equation for the ultimate moment capacity under maximum condition. Okay, so since the following are already given from beta 1 f prime c up to its dimension, meron tayong isa dito na kailangan pang isolve, which is the reduction factor. Okay, so since according sa reference natin, if we are considering the maximum condition, the Fs or the tensile strength of steel reinforcement is equivalent to 800 megapascal if maximum condition. Okay, and Fs is equals to 1000 megapascal if reduction factor is 0.9 or simply tension controlled siya. Okay, so since under maximum condition, we have first compute the reduction factor muna. Okay, kumbaga theoretically or by computation, alam natin na that a maximum condition is in between of the transition zone of the reduction factor. Okay, so yung reduction factor, meron siyang equation na 0.65 plus 0.25 quantity Fs minus Fy over 1000 minus Fy. Okay, substituting the values on this equation, 0.65 plus 0.25 quantity Fs natin under a maximum condition is 800 megapascal. So we have 800 minus yung ating yield strength of concrete na 345 megapascal. Okay, 345 over 1,000 minus 345. Okay? Therefore, yung ating reduction factor is equivalent to 0.824. Ito yung ating reduction factor. Okay? So, kung titingnan natin sa handouts natin, under the table 421.2.2 of the NSCP 2015, ito yung classification and types of reinforcements kung spiral and other conditions. So, nandito tayo sa others. So, nasa transition zone tayo. So, the main difference lang dun sa equation na ginamit natin dito is consider niya yung strain of the section. So, yung ginamit kasi natin kanina is yung kanyang tensile strength. Okay? Pero if pares lang naman sila. So, yung pinagkaiban lang dito, strain yung kinonsider niya. Diba? Strain naman is the ratio of the normal stress or Fs over the modulus of elasticity of steel. So, same lang naman sila. Okay? So, after we compute the reduction factor, pwede na natin ngayon i-compute yung ultimate moment capacity of the section. Okay? So, having the reduction factor of 0.824, quantity 51 over 140, beta factor natin na 0.85, F prime C natin na 21 megapascal, base natin is 300 millimeter, and the effective depth of 500 millimeter squared, quantity 1 minus 3 over 14 of the beta angle or beta factor of 0.85. Yung ating ultimate moment capacity is so 0.824 times 51 divided by 140, quantity 0.85, then 21 times 300 times 500 squared, quantity 1 minus 3 over 14 of the beta angle of 0.85 or beta factor, I mean. So we have 329,659,573.20 Newton millimeter. Okay. However, if we're going to convert it in terms of kilonewton meter, so in every 1 kilonewton, we have 1,000 Newton. And then in every 1 meter, we have 1,000 millimeter. So, cancel. So, yung ating ultimate moment capacity under maximum condition, we have 328.66 kilonewton meter. So this is the answer. A reinforced concrete rectangular beam having a dimension of 300 mm wide and has an effective depth of 500 mm is reinforced for tension only, assuming F prime C is equals to 21 megapascals and Fy is 345 megapascal, Using NSCP 2015 provisions, determine the balance steel ratio and determine the balance steel area required. So this one is area. Steel area. Okay. So using NSCP 2015 provision, so given natin meron tayong base width na 300 mm, yung kanyang effective depth na kapag alam naman natin that effective depth is with reference yan sa centroid ng ating reinforcements papunta sa extreme edge ng ating compression side. Okay, so yung ating effective depth is 500 mm and specified concrete strength or ang compressive strength of concrete is 21 megapascal and the yield strength of steel reinforcement is 345 megapascal. Okay, since according sa provisions ng ating NSCP, if F prime C natin is less than 28 megapascal, therefore yung ating beta 1 angle is equals to 0.85. So that is an additional given sa ating problem. Okay, so if we're going to illustrate the section, okay, so we have 300 millimeter and then with reference to the centroid of the reinforcements, ang ating effective depth ay 500 millimeter. Okay. First question, determine the balance steel ratio of this specific problem according to NSCP 2015. Okay. So, letter A, yung raw balance natin or the balance steel ratio is meron siyang formula na 0.85 F prime C beta 1 factor multiplied by 600 over Fy quantity 600 plus Fy. Yun yung ating formula for balance steel ratio. Okay? So, since lahat naman ng mga variable dito sa question is given, so we're going to direct sub the given. So, we have 0.85 F prime C natin at 21 megapascal. And beta 1 angle natin na 0.85. Okay, multiplied by 600 over Fy natin na 345 megapascal. 600 plus 345. So, cancel na yung megapascal. So, yung balance steel ratio natin is unitless. So, therefore, yung ating, by using calculator, yung ating balance steel ratio is 0.02792 unitless since this is an ratio. Okay. Since ratio to, and some problem is i-compare natin yung mga iba't ibang mga steel ratio, it is recommended that at least 5 decimal places or much better if meron silang fraction form yung ilalagay natin. Okay? Or pwede din natin i-store yung value nito para if gagamitin pa natin sa mga succeeding questions, yung sagot na ito is at least at least malapit yung sagot natin sa real value of that answer or the specific ratio. Okay? So kasi ito ay irrational number, so the more decimal places we use or we consider, the more close the real value it will get. Okay? So that is for balance till ratio, letter A. Next, for the balance still ratio area required. So ano ba yung ating area of steel reinforcements? So dito AS. Okay. So to solve AS, so we have a general equation that raw balance is AS over BD. However, since we are considering the balance condition, we must indicate also that the balance still ratio that we're going to use and the area of reinforcement is also the balance condition. Okay? Using the rule of algebra or manipulating the equation, we will get AS or area of the steel reinforcements under balance condition to be the quantity of the balance steel ratio multiplied by the dimension of the beam or raw balance BD. Okay, by substituting the given, we have 0.02792 raw balance multiplied by 300 millimeter multiplied by the effective depth of 500 millimeter. Okay, so we will have a 400 or 4,188 square millimeter AS balance condition. Next. Ngayon, dagdagan natin yung question. What if tatanong ko if ilang bang piraso yung magagamit natin na reinforcing steel bar if halimbawa gagamit tayo mo ng 32 mm diameter na RSB. How many pieces? Okay. So to do that, this area 4,188 squared millimeter, equate natin yan sa area ng this specific diameter of reinforcement. So yung kanyang area is 0.25 pi multiplied by 32 millimeter squared. So kasi itong 0.25 pi is isang piraso. Ngayon, para malaman natin yung equivalent na area dito, kailangan muna natin i-multiply yung kanyang number of pieces, which is ito din naman yung ating hinahanap. Okay, dividing both sides by 25 pi 32 squared, number of pieces na makakompute natin ay 4188 divided by 0.25 pi na 32 millimeters yung sukat. So 5.21021 pieces or roughly 6 pieces of 32 millimeter diameter bar. Okay, so kakailanganin natin ng at least 6 pieces of 32 millimeter diameter bar to get the area of steel reinforcement under balance condition. Okay, so if we're going to draw the cross section of the beam, we have okay, so meron dito na tie wire, so nato scale na lang yung ating model. Okay, so dito tatlo, so yung ating cross section release lang natin yung mga unwanted sides. Okay, so this is this is 500 millimeter, and yung ating effective or yung ating width ay 300 millimeter. Okay, tapos 6 pieces ng 32 millimeter diameter bar. Okay, so ganyan natin i-illustrate yung cross section ng ating beam with reference sa problem natin dito.